All right, this is Math 102, 16.1 on quadratic equations. So up until this point, all we have known how to do is to solve quadratics by factoring. So we're going to kind of review this, and then we're going to go into a new method called the square root property. So in the past, what we would do is we would come over here, we would set our quadratic equation equal to 0 by adding 16 to both sides. We would factor it so that we would look for factors of positive 16 that make negative 10, which is going to be negative 8 and negative 2. And then we would set each of these factors equal to 0 and then solve it. So we would get one solution is positive 8 and the other solution is positive 2. When we go to the next one over here to the right, we are going to start by the same thing. And then we're always going to try and pull out a GCF. So when we look at this, we get 4x squared minus 24x plus 36 is equal to 0. I can take out a 4 out of all of those terms, so I want to factor that out so that I get this, x squared minus 6x plus 9, and then I am going to find factors of 9 that add up to negative 6, which makes that negative 3 and negative 3. Now, I only have to set factors that have a variable equal to 0 because 4 will never equal 0. So that just helps me in the factoring process. And then I really only have to do this one time and I get a solution of positive 3. I don't have to set up the same factor twice. I'm only going to get the one answer. So remember, that little x squared, this little exponent right here, tells me that I'm going to have at most two solutions, okay? And then the last one we're going to do x squared minus 16 equals 0. This is a difference of two squares. So I'm going to have x plus 4 and x minus 4 as my factors. And then I will solve and get one solution is negative 4, and then the other solution is positive 4. Okay, so factoring was the only way that we had to solve a quadratic equation. Now we're going to look at what is called the square root property. So the square root property says if I have x squared equal to a c, then I will have both the positive and the negative values of the square root of c. So both positive and negative values. So the goal is remember that you have to have your squared on one side, whether it be a single variable or whether it be a parentheses and a group in parentheses being squared, equal to a c. And then we can take the square root of both sides. So what I do here is I like to do this. I take the square root of x squared and the square root of 49. This little 2 right here cancels out this 2, and that leaves me with x. And then I have to put both the positive and negative value of the square root of 49, which makes that 7. So sometimes Hawks will have you listed as a positive 7 and a negative 7, and sometimes they will allow you to list it as a plus and minus. So there is a plus and minus on your math palette as a tool that you can sometimes enter there. Okay? But the goal is that you have to have the variable isolated by itself squared on one side before you can take the square root property. So here I must add 4 to both sides. So now I get 2x squared is equal to 4. I still don't have the x squared by itself, so I have to divide by 2. And now I get x squared is equal to 2. And once I get that, then I can take the square root of both sides. And I just like to cross that off. And as soon as you write the equal sign, follow it with a plus or minus, and that can't be simplified any further. So plus or minus the square root of 2 is my final answer. You only simplify the radical if it can completely come out or if parts of it can come out, okay? So now we have this one where you take the square root, we take the square root, this 2 cancels that, and so I'm left with y plus 6 is equal to plus or minus. The square root of 16 is a perfect square, so that gives me 4. Now, my goal is to find out what y is. So now I have to subtract, and I always put that number in front of the plus or minus. So y is equal to negative 6 plus or minus 4. Now, the problem with this is that if I have anything but numbers left, okay, there's no radicals, there's no imaginaries, there's just numbers, negative 6 and 4, then I actually have to find both of my solutions. So I like to say the first solution, which I call y1, is negative 6 plus 4, which is negative 2. And the second solution is negative 6 minus 4, which is negative 10. So when you enter this in Hawks, it will have 2 boxes, and you will put in those boxes the solutions, and it doesn't matter which ones you put in which box. Now, if they only have one box, then you would simply separate those numbers by commas, okay? All right, so now let's try the next one. So here we're set up. We have a squared equal to a constant. So we take the square root of both sides. That cancels, and I'm left with 6x minus 12 equals plus or minus. And I'm going to go ahead and simplify this because there's a perfect square in there. And the square root of 4 is 2, and the square root of 3 stays the square root of 3. So now I'm going to add 12 because I have to get the x by itself. So 6x is equal to 12 plus or minus 2 radical 3. And then I'm going to divide everything by 6. And so my final answer is x equals 12 divided by 6 is 2, plus or minus, the 2 becomes a 1, and the 6 becomes a 3, and so I have radical 3 over 3. Okay, so some of these answers are going to be very tricky when you write them out. You just have to be very clear on making sure that you have the denominator where it needs to be, and if something simplifies, you get rid of it, okay? So the first thing we do here on the next one is we're going to divide by 3. So 96 divided by 3 is 32. So we get y plus 4 in parentheses squared is equal to 32. Now we are able to take the square root of both sides, and that 2 cancels that 2, so we get y plus 4 equals plus or minus. As soon as you write that equal sign, follow it with a plus or minus. And 32 is 16 times 2, and 16, the square root of 16 is 4, and the square root of 2 stays a 2. And then last but not least, we will move over the 4. And so y is equal to negative 4 plus or minus 4 radical 2. Okay? All right, so let's eliminate this 3 by dividing through. So x squared is equal to 27. Now we take the square root of the left, the square root of the right, cross that off. X equals plus or minus 27 is 9 times 3, and the square root of 9 is 3, and the square root of 3 stays in. So plus or minus 3 radical 3. Okay? And the reason that we do this square root property is because when we do the next section, you're going to have to get to this stage where you can use this square root property. So divide by 81, we get y squared equals 1. Take the square root of both sides. So y equals both positive and negative, and 1 is a perfect square. So a lot of times students miss these problems because they only get one solution and they get the positive solution. They forget that the negative is also a solution. Okay, so we divide through by 6, and 144 divided by 6 is 24. So x squared is equal to 24. We take the square root. So x equals plus or minus 24 is 4 times 6. The square root of 4 is 2. The square root of 6 stays the same. So again, you can write it as 2 radical 6 or negative 2 radical 6. Okay. The next ones, again, we're already set up. We have something squared equal to a number. So then we can go ahead and take the square root of both sides. So 3y plus 9, that comes out because the squares cancel each other. Plus or minus 8 is 4 times 2. The square root of 4 is 2. And the 2 stays in the radical. Now we subtract 9. That goes in front of the plus or minus. So 3y is negative 9 plus or minus 2 radical 2. And then we divide everything by 3. So y is equal to negative 9 divided by 3 is negative 3 plus or minus 2 radical 2, and that is still over 3. So like I said, you want to be really careful when you enter these answers that you don't have a 3 underneath the negative 3, that only the fraction is underneath the 2 radical 2. Okay? Now we divide by 49. So x squared is equal to 1 over 49. We take the square root of both sides. That cancels. And x equals plus or minus the square root of 1 over the square root of 49, which is plus or minus 1/7. Now, the last two are special cases because we're going to have an imaginary number. Remember, when we take the square root of a negative root, now we have something to put in there. So just recall from 15(8), 15(9), the square root of negative 1 is I. Okay, so we're going to take the square root of both of these, and this becomes x equals plus or minus, and that becomes 5, because square root of 25 is 5, and the square root of negative 1 is I. And we always put the number in front of the variable, just like we do, if it was an x, okay? And this one, same idea. We take the square root of both sides. This 2 cancels that. X plus 8 equals plus or minus. Remember, this is going to break up into 9 times negative 1. And the square root of 9 is 3. And the square root of negative 1 is I. And then we can move over the 8 by subtracting. So x is equal to negative 8 plus or minus 3i. And you can write it separately if you want. Separate it by commas. And those are your two solutions. So one of the things that we will do with this process is we will look at some applications that are talking about using the Pythagorean theorem. So here's your Pythagorean theorem where A is a leg, B is a leg, and C is what we call the hypotenuse. And that's always the side that's diagonal from the right angle. And it's always the longest side. So what I always tell students here is that there's an easier way to do this. We can substitute this in, but we could write a formula is where we have a leg squared plus a leg squared is equal to the hypotenuse squared. Okay. And so then we can make a kind of a shortcut so that we don't have to do any solving. We can solve and move things around using these formulas. So if I take a squared plus b squared equals c squared, if I'm looking for c, okay, then I would say that c is going to equal the square root of a squared plus b squared, okay? Now, because we're dealing with applications, we don't have to put the plus and minus. We only have positive distances, okay? So what I'm going to do is I'm going to plug these in. C is what I'm looking for, the square root of 9 squared plus 12 squared. So that gives me the square root of 81 plus 144, which if I add those up, that gives me the square root of, let's see, I think that's 225. 144 plus 81, yep, 225. And then if I take the square root of 225, that is a perfect square. So C is equal to 15. Now, in this case, I'm looking for B, so I'm going to give you a shortcut formula. A squared plus B squared equals C squared is my original formula. If I subtract A squared from both sides, I get B squared is equal to C squared minus A squared. And if I solve for B, which is what I want, I take the square root of both sides. So now I can plug in what I know. So B is equal to the square root of C is 12, so 12 squared. A is 6, so 6 squared. So B is equal to 144 minus 36. And that equals 108. And I don't know if there's any perfect square in there. Do I write 2, 8 divided by 36. Yep. So 108 is 36 times 3. And the square root of 36, the square root of 3, so that would be 6 radical 3. That is your distance for B, okay? And I believe this is the last one. So again, we're looking for B, so let's do B. And it is the square root of C, which is radical 2 squared, minus A, which is 1 squared. And so the square root of 2 squared is the square root of 4, and the square root of 4 is 2. Whoops, I forgot my square here. Minus 1, because 1 squared is just 1. And so that is the square root of 1, which is equal to 1. And this is actually a special triangle. It's a 45, 45, 90-degree triangle where the lengths of both of the legs are the same. Okay, so that finishes 16.1.